Number 20, again, you're really just adding on an x. That's the shortcut. So this one is going to be negative 1x plus c, or I guess I can rewrite that a little bit simpler as negative x plus c. And for this last one, it's just going to be kx plus c. Whenever I have some constant, all I have to do is add on an x. Don't forget my cake, and I've got the answer. Negatives are where we start making more arithmetic errors. I don't know how you want to pronounce it. I guess arithmetic errors. I had negative 2 for the power, so it was 4x to the negative 2, but it's adding 1. If I add 1 negative 2, I get negative 1, and I divide down by negative 1. Don't forget my constant of integration, my c. And I can reduce this thing. I can say that's equal to, I'll come over here on the left-hand side so I don't run into the next problem. That's really just, I guess you can write it as two ways. You can write it as negative 4x to the negative 1 plus c. Let me move this over even more. Or you could write it as, I'll do another answer in yellow, I guess. That's the same thing as negative 4 over x plus c. Those are all three the same answer. Either one of these two are considered correct. I guess since it gave us a negative power, our answer should be a negative power. Just give it like you, give the answer as you found the answer. So I think that's kind of the logic that I'm going to be using. So it was, let me switch to blue here. It was negative 2x to the negative 2. I'm going to add a power. It becomes negative 1 plus, or don't forget to divide down, divide by negative 1 plus c, which means my final answer is just 2x to the negative 1 plus c. Again, I could have written that as 2 over x plus c. I'm going to write it with negative powers instead of fractions, though. And similarly over here, I have ax. It used to be the negative 2. It turns into negative 1. Divide down by negative 1, which is really the same thing as just putting that negative out front, and plus c. Divided by negative 1 is the same thing as multiplying by negative 1. That's kind of the rule that I'm using right there. For number 25, the integral of f of x, this is kind of that definition question that you need to know. It's capital F of x. Don't forget your cake, plus c. Box it, final answer. If I go forwards, I take the derivative, and then once backwards, I'm left with what I started with, which was just f of x, lowercase f of x, plus c. Go forwards twice, backwards once. I'm left with going forwards once. The answer here is f prime of x. Don't forget your plus c. All right, now I'm going to have to start changing the form. All of the rest of these, I have to change the form. These I have to distribute. So changing the form, I'm going to rewrite this as the integral of 3x to the negative 2 dx. And now I'm going to take the derivative after rewriting the form. It used to be 3x to the negative 2, I'm going to add 1, it becomes negative 1, and then divide down by negative 1, which is the same thing as multiplying by negative 1, and then plus c. And because it gave it to me as a fraction, I'm going to give my answer as a fraction. So my answer is negative 3, make my 3 slightly neater, negative 3 over x plus c. Again, I'm going to have to rewrite my form, so this is rewritten. I'm still having the integral. I haven't taken the integral yet, so I'm leaving it there. This is still negative 6x to the negative 3 dx. And now I'm going to take the antiderivative. So I used to have negative 6x to the negative 3. I'm going to add 1. It becomes negative 2, and divide down by that negative 2 plus c. Simplify. This becomes a 3. Oh, I'm not quite there yet. This turns into a 3x to the negative 2 plus c. And now I'm going to rewrite it backwards as a fraction because the answer, or the problem was given as a fraction. And this is going to be 3 over x squared plus c. Final answer, box it. Again, rewriting this. This is going to be the integral of a x to the negative 3 dx. When I take the antiderivative, the integral and the dx will go away, and I'm left with ax. It was negative 3. I'm going to go up a power. Negative 3 plus 1 is negative 2. Divide down by that negative 2, and plus c. So my final answer, there's no reducing I can do. I can just make this so there's no negative powers. And that will be a over negative 2x squared that's supposed to be squared right there, plus c, and box it. Number 31. Again, rewriting this form. I still have -9, and this x to the power 4 is being brought up, so it's x to the power of -4 now, dx. From here, I'm going to take the antiderivative, so I'm going to rewrite this is -9x. It was a -4. I'm going to add 1 to that. It becomes -3, and then divide down by that -3. Don't forget your plus c. I can simplify that fraction. Negative divided by negative is a positive. 9 divided by 3 is 3, so I really have 3x to the -3 plus c, and then get rid of the negative exponents. The problem was given with positive exponents. And this is going to be 3 over x cubed plus c. Final answer, box it. Number 32, again, rewriting the form. Still have the integral there. It's 2x to the -5, now that's brought to the numerator, dx. Then when I take the antiderivative, this is now going to be 2x to the -4, because I'm adding 1 to -5 to get -4. And don't forget I have to divide down by -4, then plus c. Reducing that and getting rid of the negative exponent all at once, this is going to turn into -1/2. So -1 over 2x to the power 4 plus c. I did two things in the same step there. I'll re-explain it. The -1 over 2 is coming from the simplification, and x to the -4 goes to the denominator and becomes x to the positive 4. Number 33, I'm rewriting that as the integral of x to the -4. That one kind of disappeared. It was there, but it's the same thing as just writing x to the -4 dx. When I take the antiderivative, it goes and turns into x to the -4 plus 1, which is -3. And then divide down by -3. Don't forget your plus c. Rewriting it without negative exponents leaves us with 1, nothing on the top, so just 1 over -3x to the positive 3 power plus c. Final answer, box it. Number 34, getting rid of this radical symbol. This is really the integral of x to the 1/2 power dx. So taking the antiderivative, this is now x to the power of, I go up a power, I add 1 to 1/2, and I get 1.5, or 3/2. And then divide down. So that's the same thing as dividing by 3/2, which is the same thing as, and I should leave my, oh no, I should leave my plus c in there still as well. Plus c. That is the same thing as x to the power of 3/2 divided by 3/2, and then plus c, of course. I don't want to forget that guy. So I'm going to keep, change, flip it, and I'm going to not show this step anymore. I'm going to condense it. So I really have, and I'll do this in red, 2/3 x to the 3/2 plus c. So I'm going to be flipping whatever this power is from here on out and multiplying that. So I could have skipped it, flipped it, 2/3, and put the 2/3 out front, 2/3 out front. Number 35, I can rewrite this as the integral of 2x to the 1/2 dx. Taking the antiderivative, this is now going to be 2 out front still. I have x, I'm giving myself some room here because I know something's going to happen. So I have x to the power of, it was 1/2, I go up a power to 3/2, and then I divide by 3/2, which is the same thing as multiplying by 2/3, and then don't forget my plus c, and then 2 times 2 is 4. So my final answer here is 4/3 x to the power of 3/2. Ooh, I'm realizing I'm kind of making a mistake here. I'm just going to leave it as 3/2 plus c because it's nice and simple. But I'm realizing that the question was given to us in radical form, and we're not leaving it in radical form. This should technically be 4/3 square root of x cubed plus c, I suppose. But I think that's fine. This one should be rewritten as integral of 3x to the 1/2 dx. When we convert that, or when we take the antiderivative, we now have 3, and then leave some room, x to the power of 3/2 multiply by the reciprocal, so 2/3 is being multiplied, and plus c. Simplifying that becomes, oh, the 3's kind of cross cancel, So I'm just left with 2x to the power of 3 halves plus c. Final answer, box it. We have some more radicals. Got to convert the form. This is now the integral of x to the negative 1/2 dx. Negative because it was on the bottom, 1/2 because it was a square root. Now I can take the antiderivative. It's x to the power of, I go up a power to the 1/2. 1 minus a half is 1/2. Then divide down. Dividing by 1/2 is the same thing as multiplying by 2, so multiply by 2 plus c. Final answer, box it. Rewriting this form, I have the integral of, I still have the 2, and this is the negative 2, I should say, negative 2, and I have x to the negative 1/2 dx. So I still have the negative 2, leave some space here. I have x to the power of, not negative 1/2, I'm going to add 1 to negative 1/2, and I get positive 1/2. Divide by 1/2 is the same thing as multiplying by 2. And I get my plus c, which means my final answer is negative 4x to the 1/2 plus c. And I guess if I'm not really converting any of these to radical form, maybe I should be. I hope that everyone remembers that this is really negative. I can rewrite this over here. This is really the same thing as negative 4 square root of x plus c. Just rewriting it again. I'm going to leave it like this from here on out still, though. Rewriting this form, I have the integral of 2. And then this is going to be x to the negative 1/2 again, but I still have the 3 out front. So 2/3 x to the negative 1/2 dx. Again, the coefficients don't move in terms of the numerator and denominator. So taking the antiderivative, and that gives us, I still have that 2/3. Ooh, that's a weird 2. 2/3, I'm going to leave some space, x to the power of, it was negative 1/2, I add 1, I get positive 1/2. Divide by 1/2 is the same thing as multiplying by 2. Multiply by 2. And don't forget our plus c. Reducing 4 times 4. So I have 4/3 x to the power of 1/2 plus c. Final answer, box it. Remember on number 40, 41, and 42, I'm really just distributing this integral symbol. So just antiderivative of each of them. I don't have to show my work too in depth. This is going to be x to the power of, it was 3, now it's to the power of 4. Divide down by 4. I need to rewrite this form. This is the integral of x to the power of 3. That didn't need to be rewritten. But this one did. This was 7x to the negative 2 in this case. I don't have enough room for the dx. So 7x to the negative 2, it was 7x to the negative 2. I'm going to subtract 1. Let me move this over. Sorry, so it was negative 2. I'm going to add 1. I don't know why I said subtract 1. Add 1, and I get negative 1. Divide by negative 1 is the same thing as multiplying by negative 1. I guess I can just leave the negative out front. And then don't forget your plus c. I'm going to rewrite this with my final form with no negative exponents. So this is really x to the power of 4 over 4 minus 7 over x plus c. That's my final answer. And again, I'm not incorrect by leaving this last answer with a negative exponent. It's still correct, in case anyone is still thinking that. Oh man, second to last problem. Here we go. Antiderivative. I don't need to change any of the forms from here on out, so it's going to go nice and fast. It's going to be 5x to the power of, it wasn't 4, it's 5. I added 1, divide down, 5. Minus 3x, it was to the power of 2, it's now to the power of 3, divide down by 3. Plus 2x, it was to the power of 1, now it's to the power of 2, divide down by 2. Plus 6, it was x to the power of 0, 6x to the power of 0, and it's going to be 6x to the power of 1, or just 6x. And don't forget your plus c. I can rewrite that as x to the power of 5 minus x to the power of 3 plus x squared plus 6x, oh, that's a bad 6, plus 6x plus c. And that is my final answer, box it. And lastly, very easy to do this guy, kind of similar. It's going to be 3x. It's not negative 3. I add 1. It's negative 2. Divide down by negative 2. Let me do a little squiggly line so we know that this is a new problem. Minus, it was a 2x to the negative 2. I add 1. It's a negative 1, which means that this is a double negative here. Plus x to the power of 4. It goes up to the power of 5. Divide down by 5. And then finally add, do I have enough room here? I'm going to have to come down to the next line, aren't I? Plus 16x, it was to the power of 7, now it's to the power of 8, divide by 8. And I should have moved that over a little bit because I need to do a plus c as well. If I zoomed in, I probably would have been able to do all this. Plus c. And then my final answer, I can write a little bit neater. And I'm going to get, since it gave me negative exponents, I'm going to leave negative exponents. I'm going to be like that. So I have 3x to the negative 2 divided by 2. I guess that's a negative out front. And then I'm going to add 2x to the negative 1. Add x to the power of 5 over 5. Add 2x to the 8. And I need to squeeze in a plus c here. Plus, no, I don't need to go to a page number. Plus, it's trying to go to the page number because I click on the page. What if I zoom in down here? Plus c. Whew, okay. Barely managed to squeeze it in here. There it is. All right, that is the end of the worksheet, 5-1.